you use statistics as plural word. For singular, statistics numerical data. Okay, these statistics utilize both singular and plural. Now I'm telling about arithmetic mean. Arithmetic MEAN. Arithmetic mean. Arithmetic mean is calculated for three different types of data. One is individual data, and another is discrete, and another is continuous data. What is mean by individual data, discrete data, and continuous data? First we will understand about this, later we will calculate arithmetic mean. First, individual data means data, each observation has frequency 1, means 2, 4, 6, 8. Each observation frequency is 1, means no repetition occurs in this data. That is called individual data. Okay, individual data is no repetition occurs. Every observation frequency is 1. Discrete data, same 2, 4, 6, 8, but frequency is varies from observation to observation. Means frequency is 4, frequency is 8, frequency is 2, frequency is 7. This is discrete data. Discrete data has frequency which varies from observation to observation. Individual data, unit frequency observation. Data. Continuous data consists of class intervals. These class intervals are two types. Those are two types. Those are inclusive and exclusive. Continuous data has class intervals, and these class intervals are two types: inclusive and exclusive type. I am going to tell about example about inclusive type. Inclusive. In inclusive, the data class intervals are looking like this: 10 to 19, 19 to 20 to 29,
Sir, you are muted, sir. Please unmute yourself. Hello, sir. Please unmute yourself.
Hello? Hello?
Yes, sir. It's working now.
I-
Yes, sir. You were muted for a while.
Okay. Is it visible properly?
Yes, yes. Visible.
Hello?
Everything. Please carry on. Please carry on.
In exclusive type, we exclude these upper class limit. We are excluding. So that's why it is called exclusive. Here we are including both class
Yes, sir. It is
limits.
visible.
Okay. So that's why it's called exclusive and inclusive. We can convert exclusive class in. We can convert inclusive class intervals into exclusive form. We can convert inclusive into exclusive form. For drawing histogram, we will convert inclusive into exclusive. How to convert inclusive into exclusive? We will take upper class limit of previous plus lower class limit of next class interval divided by 2, means 19 plus 20 by 2. We will get 19.5. Now we will change these limits. These are 19.5 and here are 19.5. Like this, we will add plus 5 here and we will subtract minus 5 here. 29.5. Like this, we will convert inclusive into exclusive. It is useful for forming histogram and frequency polygon, frequency curve, and so many things. Now, arithmetic mean, we can calculate three types of data: individual, discrete, and continuous. For individual data, the formula is just observations. Xi, ith observation, suppose 2, 3, 7, 1. The mean x bar equals to summation of xi by number of observations. Actually, formula is n. Okay, number of observations. This is summation of xi by n x bar. For individual, we can calculate mean in two other forms. That is deviation form and step deviation form. For individual series, we can calculate mean by deviation form and step deviation form. This is basic formula. We use two different formulas to calculate mean. When these deviation and step deviation formulas are useful, suppose our data has values like 100, 150, 200, very big values. In order to calculate mean, we need to make this calculation so much simple. That's why we will do some modification. Suppose consider these are xi values. Now xi minus some value we are subtracting. This is called division. Okay. Hello. Hello students, is it okay? Hello. Hello. Hello students, is it okay? Shall I continue?
Yes, please continue.
I minus a some value. some constant value. This is constant equal to D. Okay. Now we will find the formula. Okay. Now I am going to find out the mean formula in deviation form. What we are doing is xi minus a equals to D. Now take summation on both sides. Summation here and summation here. This is I equals to 1 to n. Here also I equals to 1 to n. N means size of the data. Now take summation inside. Summation of xi I equals to 1 to n minus summation of a I equals to 1 to n equals to summation of d I equals to 1 to. Now divide both sides by n. Then it becomes x bar minus summation of a I equals to 1 to n by n equals to d bar. Now this is constant sum up to n times, it becomes n times of that constant. N times of that constant. Now cancel this n, you will get x bar minus a equals to d bar. X bar equals to take this a this side, and the formula becomes x bar equals to d bar plus a, or a plus d bar. In most of books we will say this a d bar. X bar equals to. This is deviation form. Now step deviation form. Step deviation form. It is also very simple. Take x value, subtract by a divided by h equals to d. Now send these h to that side. Xi minus a equal to h times of d. Now take summation both sides of the di. Take summation both sides. Here also summation I equals to 1 to n, I equals to 1 to n. Both sides n and n. Now send this summation inside. It becomes summation of xi by n minus summation a by n equals to, here h is constant. Here h is constant, h is a number. Take outside summation of di by n. Okay, here you will get x bar minus summation of a constant n times equals to n times of a. Sorry, n times a by n. Cancel these terms, equals to h d bar. Now we get the formula x bar equals to h d bar plus a, or h a plus d bar into h. Okay, understand? Hello, everyone understand this? Once once again I'm repeating today's class. Shall I repeat or shall I continue from starting? Hello? Hello, students. Shall I repeat or shall I continue?
Continue.
Hello?
Continue. Sir, continue.
Okay. In arithmetic mean, individual part is over. Now we are going to enter about discrete part. Discrete. Okay, this is over. Okay, now I am going to tell about discrete part. Okay. I denotes ith value I, and frequency. In discrete, we introduce this term as frequency. Frequency means repetition of number of times that same value repeated. Frequency. Sometimes we can call this is as weightage also. Weightage also, no problem. Okay. In weighted arithmetic mean, instead of taking as frequency, we will take here as weight for corresponding value. Suppose 2, we will weight 4. Suppose 3, we will give weight 8. This weightage is useful for calculating CGPA. I think you know the formula CGPA. Suppose this is subject mathematics. Here, instead of giving frequency, we will do weightage for that subject is 3 credits. Nothing but credits. Mathematics 3, physics 4, English 2. Okay, these are not frequency, these are weights. Okay, and science 5 like this. Okay, sometimes we can interchange these things. Okay, in discrete, the formula for mean is summation of fi into xi by summation of fi. Summation of fi into xi divided by summation of fi. Fi summation of fi. This is whole frequency. We can denote by capital N. We can write like this: summation of fi into xi by n. Shall I do the proof of this formula? No need. Your wish. How this formula came? Fi into xi. Hello. Shall I do the proof of this formula, discrete formula? This is very simple proof also. The proof is xi corresponding fi. This is x1 corresponding is 1, x2, f2. Okay, like this. Suppose this frequency is 2 times. Okay, this is 3 times. Okay, we can write like this. Okay, x1 x1 2 times, frequency is 1, x2 x2, these are 1 frequency, the x values. I am converting these discrete frequency table, frequency distribution into individual form. We can convert like this: x1 repeated 2 times means x1 x1, x2 repeated 3 times means x2 x2 x2. We know the formula for individual. What is the formula for individual is summation of these values, means x1 plus x1 plus x2 plus x2 plus x2 divided by 1, 2, 3, 4, 5. We can write these as like this: 2 times repeated x1, so 2 times of f1, these are 2 times x1, this is 3 times of x2. Okay, this is nothing but frequency f1, so you can write like this: x1 into f1, x2 into f2, like this, plus x3 into f3, x4 into f4, like this. So you can write this formula: summation of fi into xi divided by, this is total frequency, and this is the formula x bar. Students, is it okay? Students, do you have any doubts? Hello? Students, if you have any doubts, please ask. Hello? More.
Students, you can unmute yourself and ask the query if you have.
Yes. Students, do you have any doubts, any queries? You can ask freely. If you understand these basics, then you can understand later complicated, complex statistics. Okay, I'm continuing.
Seems no doubt, sir. It seems no doubt is there, sir.
Okay. Okay. This is discrete formula proof. Now, continuous data. Continuous data. In continuous data, here class intervals, their frequency, these two are available. Okay, these are like this: 10 to 20, 22, 30, 32, 40. For calculating mean, we need to make classes, okay, like continuous. Okay, there should no between these class intervals. Okay, and frequency, suppose this is frequency of f1, f2, this is f3. Now how to calculate the mean is, first we will calculate midpoint. Midpoint means it is the average of these two limits. 10 plus 20 by 2, it is 15. It is 25, 35. I am denoting as M, midpoint. Now x bar equals to summation of multiply this midpoint and this F1 midpoint. This is M1. This is M2, M3. Here we are assuming that these values are closely concentrated around this midpoint. Means whatever the values present inside this interval, suppose 22, 28, 27, those are closely situated or concentrated around this mid value. This is our assumption. X bar equals to summation of mi into fi by capital N. Here capital N equals to summation of fi. I equals to 1 to summation of I equal to 1 to small m. Okay, small n means this is 1, 2, 3, 4. These are small n means. Okay, suppose here these are 3 class intervals. I will take 3 here. First frequency is f1 plus f2 plus f3. We will get capital N. Don't use with the small n and capital N. Small n is number of class intervals here. Small n. The formula is x bar to summation of mi into fi I equals to 1 small n divided by summation of fi I equals to 1 to small n. This is small n. Entire this thing is capital N. Okay. Now this is arithmetic mean. Now geometric mean. Geometric mean equals to, suppose observations x1, x2, x3 up to xn. Geometric mean also we can find for 3 types of data: individual, discrete, it has frequency extra. Okay, here unit frequency, individual, this is frequency, this is continuous. Geometric mean we can calculate for these 3 types of data. Suppose this is individual, means each observation has frequency 1. Now geometric mean equals to product of, here we do product. In arithmetic mean we do summation. It is product of xi. I equals to 1 to n. N means here number of observations whole to the power 1 by small n. This is geometric mean, product of xi equals to 1 to n, 1 by n. This is for individual data. Now we will represent in another form, log form, okay, of this same formula. Now apply logarithm both sides. If you have logarithm be natural logarithm, I am applying natural logarithm, not common logarithm. You can apply any logarithm, natural logarithm, common logarithm, binary logarithm, any logarithm. Yes, no problem. Okay, but most convenient is natural logarithm. I am applying natural logarithm. Okay, apply both sides ln, natural logarithm, and natural L logarithm. Gm equals to, I think you know, log m power n equals to n times of log m, any base, no problem, base. Log m raised to n equals to n log m. So here ln product of xi whole raised to n, this is this part. So this will come first. So it becomes 1 by n log ln product of xi I equals to 1 to small n is ln gm. Ln gm equals to 1 by n ln product of xi. Okay, now you know the formula of ln x into y equals to ln x plus ln y. Ln of product equals to sum of logarithms of those observations. Ln of product of observations equals to sum of logarithms of those observations. We are going to apply the same formula here, same rule. So 1 by n product means here we will get summation of ln xi I equals to 1 to small n. Here this is ln geometric mean. See, it is looking like mathematic mean of logarithm of values. It is looking like arithmetic mean of logarithm of those observations. Arithmetic mean is looking like this summation. Okay, take this as I you will understand. Okay, 1 by n summation of yi I equals to 1 to n. Ln gm equals to 1 by n summation of yi I equal to 1 to n. Okay, now for discrete. Now for discrete values, we are going to calculate geometric mean for discrete values. Here observations are x has frequency component. Now geometric mean formula is geometric mean equals to summation of product of xi whole raised to fi, xi whole raised to f whole to the power 1 by summation of fi I equals to 1 to small n. Gm equals to product of xi whole raised to fi I equals to 1 to small n. Small n, this is small n whole to the power of 1 by summation of fi, or you can write like this 1 by capital N. Instead of this you can write 1 by capital N. This is the formula for discrete. Here you will get frequency component. Now we will write in logarithmic form. This is also same procedure. Apply ln gm equals to, take this to 1 by n summation 1 by n ln inside this product of I equals to 1 to n xi whole raised to fi 1 by n ln product of I equals to 1 to n xi whole raised to, not whole raised to, xi raised to fi. Now use that formula, that ln of product of observation equal to sum of logarithm of those observations, that formula. Okay, ln gm equals to 1 by n, ln gm equals to 1 by n ln product of xi. Okay, summation of ln xi whole raised to xi raised to fi I equals to 1 to small n. We can get this here also. 1 by n summation of I equals to 1 to small n fi ln x fi ln xi. This is logarithmic representation of geometric mean. Now we will do one thing. Take this ln this side. So geometric mean equals to, if n go to this side, it is become e. ln goes to this side, it is become e. Okay, e raised to 1 by n summation of fi ln xi I equals to 1 to n. If you take natural logarithm, then it is become small e. E means 2.718. E equal to 2.718. This is Euler's number. It is a constant. E equals to e 1 by n summation fi ln xi. Suppose if you are interested to take other base, suppose log of any base, suppose a, okay, of gm equals to 1 by n summation I equals to 1 to small n fi ln xi. This is other than natural logarithm, any base. Okay, now if you want to find out the geometric mean, you need to send this log to this side. Then you can write like this: anti-log. Means we didn't specify any base, that's why I'm writing like anti-log. Here we specified it is natural logarithm, that's why it is converted into e. Otherwise write like this: anti-log 1 by n summation fi ln xi I equals to 1 to small n. Is anti-log because we didn't specify any base. Here it is e constant because we specified natural logarithm. Students, any doubts about this? Any doubts? Student, any doubt till now? Hello, sir.
Yes, sir. Yes, sir.
Is there any doubt?
No, in one chat box, one person texted, there is no doubt, sir, like that.
Okay.
Okay, sir.
Okay. I am repeating once again something. Okay. This is main thing you have to.
Yes, sir. Please summarize, sir, please.
Hello. Hello.
Yes, sir.
I am not understanding.
No, sir, I didn't heard clearly what you said, sir.
Shall I revise?
Yes, sir. Yes, sir. You can, sir.
Yes, sir.
Okay. Now I am writing like flowchart. Okay. I remember this. Okay. Okay. First is statistics. Okay. These are divided into two branches: inferential and descriptive. Okay. In descriptive, it is divided into two parts: numerical and graphical. In numerical, it is divided into three parts: measures of central tendency, measures of dispersion, measures of direction. In measures of central tendency, these are divided into mathematical and positional. In positional, divided into median, mode, and some also there are some more topics also there. Those are quartiles, deciles, percentiles, median, mode, quartiles, deciles, percentiles. In mathematical, these are divided into three: AM, geometric mean, harmonic mean. In arithmetic mean, it is calculated for three types of data. Those are individual, discrete, and continuous. Now today we covered up to arithmetic, these things: statistics, discrete, numerical, central tendency, mathematical, arithmetic, main completed, and geometric mean also completed for individual and discrete. For continuous we will do. Okay. Now geometric mean for continuous data. We will get class interval and frequency, respective frequency, Fi. Okay. Here 10 to 20, 20 to 30. Suppose this is F1, this is F2. In geometric mean also we will find midpoint. Midpoint. This is 15. This is 25. This is M1. This is M2. Geometric mean for continuous equals to product of Mi raised to Fi whole 1 by capital N. 1 by capital equals to 1 to small n. Small means this is first class interval, second class interval. If you substitute 1, you get this frequency. 2 means this frequency. Only 2. This is small n. Same mathematical application, we will get same formulas. We will get like this. Okay. Ln Gm equals to 1 by n summation of Fi ln Mi I equals to 1 to small n. This is the formula we will get. Fi ln Mi 1 by n, I equal to 1 to n, small fi ln Mi. This is ln Gm. If you take this to this side, just it becomes small e, small e, small e. Okay. This is geometric mean. The drawback of geometric mean is what is the formula for geometric mean is geometric mean equal to, suppose for individual data, geometric mean equal to product of xi whole to the power of 1 by n, I equals to 1 to small n. Suppose if any one value is 0, the entire geometric mean becomes 0. This is not a good representation of data. Means single value making entire data into different interpretation. Okay. If single value equals to 0, the entire geometric mean becomes 0. Okay. by looking this 0, we cannot tell about the type of data. Suppose if observations are like this, 0, 0,
Hello, sir.
0, all observations. Huh?
Hello.
Hello?
Hello, sir.
Hello,
Yes,
Sunil.
sorry, sir, to interrupt you, but we need to wind up the class in 5. There is another class scheduled on 7 o'clock. That's why we can continue in next
Okay.
class, sir.
Okay. Okay. How is today's class?
Yes, sir, it's
Hello?
good. Very nice, sir. Yes, sir. Am I audible, sir?
Yes, ma'am. Are you prepared
Yes,
for
sir. We need to wind up in 5 minutes, sir.
Okay, okay. Okay, I am stopping today's class. Okay, till geometric mean. Today geometric mean is over. Tomorrow, our next class, we will continue with the harmonic mean and measures of dispersion, measures of direction, and other topics. Correlation, regression, main topics.
Thank you, sir. Thank you, all the students, for attending the class, and hope you have enjoyed the class. If you have any query, you can ask now.
Yes.
You can unmute yourself and ask the query if you have any.
If you have any problem with this, means light problem, sound problem, or any other problems, you tell me. I will do adjust. Okay, for next class.
Yeah. Please review. How was the class? Did you like the
Feedback.
class? Yeah, please
This
give your
feed
valuable
okay.
feedback in. Yes, students. Anyone would like to say anything regarding the class? Okay, sir, no problem. It was very nice. I was there. Yes, sir. Somebody replied in the chat box. Class was very good, sir. Very informative. Thank you.
Ma'am, any problem with light, sound?
No, sir. Sound was okay. Light was also okay. No problem.
Okay, ma'am.
Okay, sir. Thank you, sir.
Shall
Students, if you have, yes, sir.
ma'am? Shall
Yes, sir.
I
Please.
tell like this from basics, or shall I tell in advanced level?
No, sir. No, sir. Please go. Means it will be easier for students to understand if you go from start
Okay, ma'am.
basic. No.
Ma'am, if the students are interested to give MSc agriculture statistics, then they prefer advanced level. If the
Yes,
students
sir.
are
That depends on which students are joining. Somebody replied that board is not clear. Okay, we will take care of that. Don't worry.
Okay,
And
ma'am.
regarding the courses and all, you can contact Vipin Naik sir, the coordinator of ACA. I think you have his number, right? So you can
Yes, ma'am.
contact them. And
Okay, ma'am.
for all the students, and regarding the registration and all the processes, and we will have the class like this, and we will try to improvise also in different aspects. So if you find any problem in the class, you can tell us. We will definitely try to solve the problem. No worry.
Ma'am,
Okay.
Okay,
ma'am,
ma'am.
ma'am, when is the
Yeah,
next
please.
class?
We will schedule the next class and we'll tell you, inform you. Don't worry.
Okay, thank you.
Thank you.
Okay, ma'am. Okay. Thank you.
Thank you so much,
Students.
sir. Thank you so much, students, for your patient hearing.
Mm. Thank you, everyone.
Yes. No, thank you, everyone. Now I'm ending the class.
Okay.
Hope to see you in the